So let's start by reading the question together. Token exchange. The carnival is back in town. Beautiful dresses and stunning wigs everywhere. Wild carnival rides and live music during the day. Loud fireworks and fun parties in the evening. Most importantly, the old fortune teller is there this year again. The old fortune teller gives luck to those who seek it, but she requires tokens in exchange for it. However, as she is so odd, she accepts two kinds of tokens, even and odd ones. She only accepts even tokens from people whose age is even, and odd tokens from people whose age is odd. Odd, is it not? Very much so. Each person needs a certain number of tokens in order to visit the fortune teller. Obviously, people whose age is odd only need odd tokens, and similarly, people whose age is even only need even tokens. However, as people still keep some tokens from last year, each person has a certain number of tokens that now do not correspond to their age. Thus, they are willing to give away these tokens to their friends, on the condition that their friends cannot distribute the received tokens further. Okay, so this is important actually, because it will make our job easier. Namely, if a person E gives a token to person O, the person O cannot give that token to anyone else. Is it possible that everyone gets the tokens they want? So this is the question. Alright, in order to understand the problem more, let's move on with the input part. So the first line of the input file contains a number T of test cases. So this is the test cases. Each of the T test cases is described as follows. It starts with a line that contains three integers n, m, k separated by space, denoting the number of people whose age is even, number of even people, number of people whose age is odd, number of odd people, and the total number of friendships. All right. The following n lines each describe tokens of people whose age is even. So for n lines, we're gonna have the even person information. The ith such line contains two integers, a and b. Okay, this is the ith line. Separated by space, denoting the number of even tokens the ith person of even age needs and the number of odd tokens they have. So this is on the ith line, there is the ith even person information, and the first integer is the number of even tokens ith person needs, and the next integer is the number of odd tokens it already has from last year. Cool. Then the following m lines describe tokens of people whose age is odd. So this is the odd aged people information. The ith such line contains two integers, c and d, separated by space, denoting the number of odd tokens ith person of odd age needs and the number of even tokens they have. So this is symmetrically the same only for odd people. The following k lines each contain two integers e and o, separated by a space, denoting that the eth even person is friends with the odd person. Note that the is friends with relation is symmetric. What does this mean? So if there's e and o, this means e is friends with o, and backwards o is also friends with e. So yeah. Output for each test case, output on a separate line, yes, if everyone can get the tokens they want. So here is fulfilled. Otherwise, you should output no. Points. There's 100 points for the first group of test sets, worth 50 points. You may assume that no person of odd age needs any tokens, that is c is equal to 3, c is equal to 0 always. For the second group of test sets, worth 50 points, there are no additional assumptions. Okay, and there are two sample cases. Sample case 1, the only even person does not need any tokens and has enough tokens for all their friends. Sample case 2, there are two people who have complementary tokens. They have one token the other person needs and the other person has a token they need. However, they are not direct friends, so they cannot share the tokens. Okay. So this is our problem. First of all, the key idea here is that for flow questions, you don't have to restrict yourself with only one single graph. You may have multiple graphs. In fact, here, our solution will have two graphs. One for even people distributing, one for odd people distributing. So, in graph 1, even people will distribute to odd people the tokens that odd people need. So, we add a source node and a sign node. And from the source we connect with every single even person. And the capacity of each edge is what even I already has. So what the ith even person already has. So the odd tokens that ith even person has. So that would correspond to B over here. Next thing, we connect every single odd person with the sink, and the capacity of that edge, each edge, is what odd j needs. So what odd j needs. So what jth odd person needs, how many odd tokens jth person needs, right? So that would correspond to capacity C over here. And we connect even and odd people only if they are friends with each other. And if they're friends with each other, then we can have a capacity of infinity. The capacity doesn't matter here because we already have the required ones there. So, and we read the is friends with relation from here. Same thing, but the opposite we do for G2. So here, now, odd people are distributing. So, from source, we connect to the odd people with a capacity of what ith or odd person already has. So, how many even tokens ith person has, ith odd person has. And then, we connect that person if, only if, he or she is friends with someone from the even people here. And that has capacity of infinity. And the even people, we connect with the sink. And those edges have the capacity of like what even j needs. So how many tokens jth even person need. So the capacities would be as the following. So what ith odd person already has would be D. What jth even person needs would be A. Okay. So what is there to check? The check was if everyone can get the tokens they want. If so, we're gonna output yes, else we're gonna output no. So from these graphs, we have two informations, the max flow from G1 and max flow from G2. And if our total max flow, so G1 max flow from G1 plus max flow from G2 is bigger than or equal to total tokens needed, then everyone can have the tokens they want, else no. So this is our thing to check. Okay. So for the coding, we can enumerate the vertices as the following. So from 0 till n minus 1, we have even people. From n till n plus m minus 1, we have odd people. And with n plus m, we denote the source. With n plus m plus 1, we denote the sync. So that's it actually. For the odd people as well, one more time. So we denote, the indexes are from 0 to m-1 for the odd people, and then starting from m going till n plus m-1 for even people, and then n plus m is the source, n plus m minus plus 1 is the sync. So what are those, like n and m? Those are the numbers from the input. So number of even people, number of odd people. So yeah, that's it. Now, how does the actual coding look like? So each flow task will consist of 4 parts. Input reading, then graph construction, then solving the problem, then outputting. So let's start by the input reading. So, okay, one more thing to realize is that from the main function, we read the integer t, so number of test cases. It's already given to us. And for t times, we call the function test case. So test case is over here. This is what we're going to code. And then it also reads integer n for us with in.readInt. Good. So that was the number of even people. Please always note to the side, if you have time, what each variable means. You don't want to mix up things. Then, as we know, m comes, number of odd people. And then k comes, number of friends. So all of this I read from my notes. So obviously it doesn't have to be this pretty, but I highly suggest to have some notes during the exam. That way you don't have to read this long text. Instead, you could just basically read this and just copy it to the code. Then, for n lines, we are going to read the information of even people first. So there are number of even tokens ith person needs, and there are number of odd tokens ith person already has. I'm going to store those two information in 2 separate arrays. So I'm going to call the first one even needs. It's gonna have the length of n because they're like n even people. And next one will be called even has. So, and for the next n line, we're going to read 2 integers. Integer a would be what the number of even tokens that ith even person needs, and then integer b would be what it has. Okay, so then I'm going to store those inside those 2 arrays. It's as simple as that. And then there are M9s for odd people, for which we're going to have exactly the same situation. That's why I'm going to copy. So it's going to be odd needs now, and odd has now. It's going to go till M. It's going to be C and D. Again, odd needs, odd has, C and D. Great. At the same time, if you remember, okay. So then we have K lines. For the friendships. And they're gonna be E and O. So that information okay. Then we can actually also read the is friends with relation and store it also. But instead of that, after we construct our graphs a little bit, I'm going to read them and then use them to add the edges on the spot. So that we don't which makes our job a bit easier. But obviously you can also read now and start it and then use it later. So for this one, our graph construction is going to be a bit blended with the input reading, which you can also do. So I want to also show that. So let's start with the graph construction a little bit. Okay. So we're going to have two graphs. So before starting with the graph construction, let's examine the graph class that is provided for us. Because we're going to use this one for creating the graph, adding the edge, and finding the flow. So let's read the comments all together. You don't have to, in an exam situation, you don't have to go through all of the code. You really don't have to. All of the things that you will need will be at the top as comments. So read it once and then copy the things that you need as you need them. So this class represents a graph with the implementation of an algorithm that finds the maximum flow. Nice. You can create a new instance of this class with the following command. Graph G is equal to new graph number of vertices. Let me just copy it here. Next thing. This will create a new graph G with num vertices. You can then access any public member of this instance in the usual way. G.addEdge 0, 1, 5. This will add an edge from vertex 0 to vertex 1 with capacity of 5. Okay. Then int max flow is equal to G.compute maximum flow of 0, 1. This will compute the maximum flow from vertex 0 source to vertex 1 sink. You may call this function multiple times, possibly with different source sink pairs. You may also call add edge to change the graph in between these calls. Okay, note that the current graph at any point in time is determined by all calls to add edge that were ever made. That is, calling compute maximum flow does not mean that later calls to add edge start with an empty graph. Great. Integer flow from u to v equals g get flow u v. After computing the maximum flow, you may want to inspect the flows on the edges. You can do this with the function getFlow. The above command stores in flow from U to V, the flow on the edge from vertex U to vertex V. Nice. Int capacity from U to V is equal to G get capacity UV. Likewise, the above command stores in capacity from U to V the capacity of the edge from vertex U to vertex V. Int number of vertices is equal to G dot get num vertices. Finally, the above command stores in number of vertices in the graph. Great. Memory usage information is also there. So my advice for this is that, so you're not coding all of this yourselves, right? So you're going to use functions already provided. Instead of copying each of those functions to the main class and then trying to remember what each of the items meant, what I suggest is that whatever you need, you come back here, you read the command there, and you understand, and then you use it. Or you can also copy the command together and then comment it out and then just have it on site. That way you will prevent making like attention mistakes. So first off, as I said, we're going to have two graphs, G1, G2. So graph G1 is equal to new graph with n plus m plus 2 vertices. Why? Because n plus m for people, plus 1 for source, plus 1 for sinks. That's sink. So this would be even people distributing. And then we will have G2 for odd people distributing. Nice. So let's start by looping through them and adding the edges from source to even. So how were we adding the edges? Let's go ahead and check. G add edge. This will add an edge from vertex 0 to vertex 1 with capacity 5. Let's copy it here. Okay. So, first of all, we're going to add an edge for every even person. So, for integer I is equal to 0, then and going to n, a plus plus we're going to add an edge from the source, so n plus m is the source, to every single even person with what capacity? What even I already has. So even has I. Nice. Next thing, let's do it from odd people to the sink. So for odd people, I starting from 0 going to m. We're going to add the edge n plus I from n plus I. So that would be like n plus 1, n plus 2, till n plus m minus 1, right? And then we're going to connect it to the sink. With what capacity? With what odd j needs. So odd needs. Right? Next thing, we need to add the friendships. So let's start with only G1 and then move on to G2 by adding. So for the friendships, we're going to read. So let's read. And what are we're going to read like K lines, right? So we're going to read two integers. Oops, sorry. Okay. And for each of those friendships, ETH even person, odd person, right? So we're going to need to add an edge with capacity infinity. So G1 dot add edge from E, because it's already starting with even person, but N plus O because it's the odd person, but the odd people start from N, so N plus O, with capacity of like something close to infinity. You need to check this. You may have an issue, but here it's not the case because of the constraints we have here. You can also use max integer. Okay, so we have the graph for G1, but how are we going to construct G2? So for G2, again, we're going to connect the source to odd people. So from 0 to M we have already here. So let's say G2 add edge from I so G2 add edge from the source M plus M to I with what capacity what odd I has. So odd I has, right? Nice. And then we're gonna need to connect even people in G2 with what even J needs. So even people loop here, G2 add edge. Now now the even people will start from so this is M minus 1, M plus 1 plus M plus 2, N plus M minus 1. So it's gonna be from M plus I to the sink with what capacity what even J needs. So even needs. Okay. And so we're gonna also need to add the edges for the friendships. So G2 add edge. Okay. So now it's from odd people to even people. So it's from odd person to M plus E with the infinity capacity again. So y M plus E again, we encoded like the following: 0 plus 1, 0, 1 to till M minus 1 because there are M odd people, and then M plus 1, M plus 2, So it's gonna be M plus E because it's the ETH even person, M plus E. Nice. So we have both of our graphs now. Okay. So to check is the total maximum flow. Is that bigger than or equal to total needed? So For that, we need to compute two things: max flow of G1, max flow of G2. Total max flow is just adding them together. But we need also the total needed. So let's start by the total needed. We could actually sum that up while reading the input. So let's say integer total need is equal to 0. And then count it as we go. Now we have it. And then we're gonna also, wait, let me delete this comment. To solve the problem, we're gonna also need to compute the flow from both graphs. So let's see how that looks like. Integer max flow is equal to G compute max flow of 0, 1. This will compute the maximum flow from vertex 0 to the sink. Okay, so this is the sort, that is the sink. So n plus m plus m plus 1. Okay, for G1, max flow G1, and then max flow G2 for G2. Nice. And then how are we going to output? So let's say also total max flow is equal to max flow of G1 plus max flow of G2. Okay. And if total max flow is bigger than or equal to total need, then this is actually outputting. So let me just focus, copy this here. Then we're gonna say yes. Else we're gonna say oops, no. So that was it. So now let's check if we have like any completion error, because that was a lot of coding. Wait, let's check. Okay, integer number is too large. First off, let's remove 1, 0. Okay. Total max flow cannot find signal. Oh yeah, because it's not integer. Yep. Okay, compilation successful. Let's test. Oh, but I have a major issue here. Now I realize why. Because I wrongly had a length of n here for odd people, but wrongly, because they are m. So now let's check. Great, after some debugging. So yeah, that was our solution. I wish you guys the full green bar for these tasks. I hope it was helpful. Sorry if you realized it way before, if you know it since the beginning. But hey, that means you're gonna do great in the exam with debugging, right? Attention to detail matters a lot. Let me know if you have any questions. Feel free to reach me. I will also provide the PDF for the notes and the code that I have over here. See you in the next video.